Binary variables are even more useful than just turning, say, include the value or not. All the OR problems need to be formulated in a standard format, which means, as I said, you cannot just put a statement there. Okay, you cannot put, say, okay, non-negativity or say inflow minus outflow equals to supply or demand. You need to write out using the decision variables. Okay. Same as some situations. We're going to look at a lot of problems that's really interesting, challenging, and in which you have to have those constraints that represent a statement such as if this happens, then this, else another. Okay, or either or situation. We can't just write those statements as a constraint. Okay, binary variables will help us formulate those kind of statements. That's why I love ILP. Okay. For example, of projects 1, 3, and 6, no more than one may be selected. I'll ask you guys to think about how to formulate the constraint for this one. So we'll just define x3, x1, 3, 6 being binaries. Okay, being binaries, 0 or 1. Representing the project selected or not. Okay, but here we have this constraint. Say, for example, from the previous problem, the manager says, okay, 1, 3, 6, no more than one may be selected. That means for those values, if x1 is 1, that means 3 and 6 need to be 0, right? No more than 1. Okay. If this is 0, this can be 1, but this have to be 0. If this both are 0, this can be 1. Or another situation is all of them being 0. None of them get selected. So that's kind of like a way for you to start analysis if you're not, if you can just get that constraint immediately out. Okay. So with this, we think, okay, so the sum of them should be less than or equal to 1. Okay. With this analysis here, exactly 1 must be selected. Equal to 1, right? Okay. Let's think about this one. 4 cannot be selected unless 5 is also selected.
X4 equal to X5?
X4 equal to X5. Okay, so what we are saying that, okay, if 4 is selected, which means it's 1, okay, then 5 has to be selected, 1. Okay, so if 4 is not selected, by using this constraint, we're saying, okay, if you don't select 4, 5 should not be selected either, which is not right, right? Because we are only saying the condition for 4 to be selected is 5 is also selected. But the condition for 5 to be selected is not that 4 also be selected. Less than equal? Okay. So with that analysis, okay, so if there's a 1, if we use less than equal to, x5 should be 1, right? If 4 is selected, 5 has to be. If 4 is 0, what happens to 5? Okay, so if 4 is 0, 5 can be 0, either 0 or 1. So we are not constraining, say, 5 need to be not selected. Okay, but when we set this 4 to be 1, 5 will be forced to be 1 because of this less than equal to sign. Okay, so we use this to force x5 to be 1. That's the condition. That's the constraint to do this one. Okay.